Okay guys, today we're going to discuss 3.2 polynomial functions. So you might want to have your Desmos handy so that you can graph some of these in a minute here. This first page though is just the names. So we'll go through some of the names of the functions and how they're named and why they're named the way they are. Alright, so a polynomial is defined as a monomial, or the sum of monomials. Any real number A, variable, or a product of real numbers and variables with whole numbers and exponents is a term. So basically we name these according to the number of terms and the highest term. The exponent of the variable if there is only one variable, or the sum of the exponents if there is more than one variable, is called the degree. So in other words, the superscript of the first term, or the leading term, provided that lead term is the highest degree, the highest exponent, is the degree of it. Alright. However, the greatest degree among monomial terms is how we classify the degree of the polynomial. Alright, so a polynomial expression, or you could say function as well if it's equal to something. So most of these are going to be expressions today because they're not going to have equal signs, but they can be functions if they have equal sign, is said to be in descending order. Or you could say standard form as well, which I used the standard form word later on in the notes, so I'll use that here too. Descending order or standard form when the terms are arranged by degree in descending numerical order. So I call it descending order. We also call it standard form in the notes today, from highest to lowest. Alright, so this looks like a lot of, this next thing here looks like a lot of variables, and it is a lot of variables. What it's saying here is that we put the highest degree first, so x to the n, and then we put subsequent degrees after that. So if there's an x to the fourth, it comes first, then the x to the cubed, then the x squared, then the x, and the constant. A0 is a constant, it has no x term. And then the an is just the leading term, leading coefficient. Alright, so when a function changes direction from upwards to downwards, it's called a turning point. So in other words, the function turns a corner. That's what we called it here in the notes here. The direction of the graph of the function as you move from as you move to the left and to the right away from the origin is often called the end behavior. This is the last keyword here. So these are the words we're going to use here today in the notes. We're going to use these words. Alrighty. Alright, so we're going to classify polynomials according to either degree or by number of terms. So the classifications by degree, I'm going to look this up right now real quick so I don't get it wrong. Degree classification. For polynomials. Okay, so the names by degree. A first degree polynomial is called a linear polynomial. A second is called a quadratic. A third is called a cubic. A fourth is called a quartic, like a quart. Q-U-A-R-T-I-C. Now the fifth technically has a name, it's called quintic, but I believe we'll just call it a n term. But we would definitely call the sixth degree a sixth degree. So if it was 6, we would call it sixth degree. Alright, and then the 0 degree is called a constant. So this polynomial example, a 0 degree polynomial would be just a single number, or it could also be an irrational number, like a square root. So like a 6 would be a 0 degree polynomial. A linear polynomial would have an x to the first power. It could also have a coefficient of that x, and it can also have a constant. So for example, 4x, I could also put a constant at the end of this, plus 2, plus 3. A quadratic has an x squared or a variable squared, so let's say for example 3a squared. The variable does not have to be x, it can be any variable. And again, I could have constants here as well. They have to be in terms of the same variable though. So if I have a squared as my quadratic degree, the next one would have to be an a. It doesn't have to be the same lead coefficient either. The same coefficient, not lead coefficient. Lead coefficient is 3. So like 6a would work. The cubic has to have a cubed somewhere in there. So like 10a to the third, or x to the third. And again, it can have a linear as well as a constant if I want. It doesn't necessarily just have to have the cubic. A quartic has a fourth power, so like 10x to the fourth, and it can just be the x to the fourth. It doesn't have to have extra terms. It can be the x to the fourth, or it can have extra terms after that. Quintic, of course, has an x to the fifth, or a variable to the fifth power, so like 7a to the fifth. And then anything after that quintic one, we're just going to say 6th, 7th, 8th, 9th, 10th degree. So 6th degree polynomial would have an x to the 6th, 8x to the 6th, or variable to the 6th, in other words. And again, it can have any number of other terms that are less than, or that have a degree of less than 6. So like a cubed term, it can have a cubed term, it can have a linear term, it can have a constant term as well, or a constant degree. Alright, so those are our names according to degree. The degree is the highest exponent, so x to the 0, 6x to the 0, x to the 0 would be 1, so that's x to the 0, degree 0. X to the first, x to the second, third, fourth, fifth, sixth. So again, all we're looking at is that highest degree, which should be the leading term when you write the polynomial out. So we'll do that in a minute, and we'll write the polynomials out from lead term to end term, from leading term until the last term. And we should always put the leading term first. Alright, the next thing we classify these by, so I'm going to leave that up. So this is classified by degree. The second way to classify polynomial is by number of terms. So if it has only one term, we call that a monomial. So that would be like this one, this one, this one, and this one, where it only has one term. It doesn't matter the degree of the term when you're naming by terms. So like for example, a 5x to the fourth, this would be a monomial. It would be a quartic monomial, but it would be a monomial. Alright, so degree, terms, different names, two different names. Binomial, mon meaning one, bi meaning two. So binomial, two terms, simply means it's got two items, like this one here and here. These are both binomials. And again, it doesn't have to start off at a particular degree. So we could start off with a 7th degree binomial. 4x to the 7th plus 6. That's a 7th degree binomial. It has the 7th degree and then it has a constant term. Those are the two terms here. A 7th degree and a constant term. A trinomial has three terms. Tri meaning three. So like this one here, this cubic degree I have right here. So we're just going to start off with whatever degree we want. So 10x to the, let's say we start off at 6 this time. It's going to have three terms. So it's going to have maybe a constant term and a linear term. Linear term, 5x, constant term, 7. And then a 4th degree, I've forgotten if that one has a specific name. I believe it does not. No, it does not. So if it has more than 3, monomial, binomial, we could, I guess we're going to put 4-nomial. Let me make sure and look that one up. Look that one up right here on the phone. So classify polynomials. By terms. Let's see what it says. Oh, quadrinomial. Like quadrinomial. There we go, I learned something new in this as well. Quadrinomial. I don't think I'm going to test you on the quadrinomial. I think I'm going to test on the monomial, binomial, and trinomial. Because I've never actually seen that word used before, personally. But that doesn't mean it can't be used. So this has 4 terms. Let's say we start off with an x cubed. That would mean we'd have to have an x squared, an x, and a constant. Because I need 4 terms. Now if I hadn't started with the x cubed, if I started with the x to the 4th, I could have gotten away with maybe not having all the different order, the whole order. But I started off with x cubed. Alright. So when we write the polynomial in standard form, put the highest degree first. So this means highest to lowest, and you do it with exponents. So the highest exponent here is the 4th. This is the highest. And then the lowest is x to the 1st. This is the lowest. So this is first, this is last. That's what I'm asking you to do here when I say put it in standard form. So the standard form of this polynomial is 5x to the 4th plus 4x squared minus 3x. The second thing here is it says name the polynomial by degree and by number of terms. So I put the degree part first. It's a 4th degree, so it's a quartic with 3 terms, trinomial. Now if you put the names in the wrong order, I'm not going to take out points for that. If I was to ask you what it is, in fact, my tests are multiple choice, the majority, so this would be like a multiple choice question and say, what is this? And it would, what is the name of this polynomial? What is the classification, I should say? What is the classification by degree and number of terms? And you pick quartic trinomial for your answer, is what you would pick. And again, as far as having to memorize these names, we're having open notes tests, so don't worry about the memorization. All right, next item here, put the x cubed first, then the 3x squared, then the 7x, and then the 2. All right, the highest exponent here is a 3rd power, so this is a cubic quadrinomial. Try the next 2 for a second here. I'll pause for 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Did you get them? If not, highest term here is a 3x, the linear term, then the 8. So this is a linear binomial. Linear binomial. Again, just pick the word from the first list. Sorry, I'm circling that. I should have circled this. Pick the word from the first list, the degree names. Then pick the word from the second list, the number of term names. 2 lists. These words are my term words, and these words are my degree words. 2 lists. Put it like that. 2 lists. Pick this one, degree, then pick this one. Alright, and then this one is well, there's no way to rewrite that. That's only got 1 term. So that's its 1 term. And it's a 7th degree. 7th degree. And it's only got the 1 term, monomial. Some of you are thinking about probably Some of you are more advanced. We're thinking about, well, can't I always just say nth degree? And the answer to that question is yes. So we could also call this a third degree quadrinomial, a fourth degree trinomial, and a first degree binomial. However, on a test that's multiple choice like we've been doing, I'm going to call this one, instead of first degree, linear. And this one, instead of third degree, cubic. And this one, instead of fourth degree, quartic. Because those are the proper names for them. So yes, you can always use nth degree for that. And in terms of the number of terms, if there are 5 terms, we could say 5 nomial, 5 nomial, 3 nomial, 2 nomial, 1 nomial, 4 nomial. But again, I'm going to use the proper words for these first 3. And this fourth one, I'm not going to use the quadrinomial word. All right. End behavior of polynomials. So we talked about this in the past. Either a polynomial is going to point up or it's going to point down. Smiley face, frown face for your even functions. Alright, so the degree of polynomial affects the shape of the graph and determines the maximum number of turning points. So for example, for an x to the 4th polynomial, it has 3 turns. 1, 2, 3. And x squared only has 1 turning point. So that's the maximum number of turning points. It doesn't mean that's the number of points it has to turn, it's the maximum number of turning points. So this one has a maximum of 4 turning points, this one has a maximum of 1 turning point because of the degree. So the turning points, this turning points is going to equal the degree minus 1. And that's the maximum number of turning points, max amount. That doesn't mean that's always what it has. So an x to the 4th will not always have 3 turning points. It will have a maximum of 3 turning points. For example, if I graph just the base x to the 4th function on my Desmos calculator here, if I were to graph just the basic x to the 4th, x and to the 4th, it only has 1 turning point because it doesn't have anything else besides the x to the 4th in it. It just has this turning point right here at 0, 0. But if I were to graph this one has 3 turning points. These 2 on the bottom, and then this one in the middle. Turning points means it has a maximum or minimum is what we call those. A turn in the function. This one is x squared. It can only have a maximum of 1 turning point. That's why it only turns at the top. It points down because the lead coefficient is negative. Alright, the odd functions, again, same thing. This one has a maximum of 2 turning points, and this one does as well because x cubed, and it has both turning points. Now, I'm not going to ask you to understand how many turning points it has just by looking at it. What I would expect you to do is to graph these to determine the turning points, the maximums and the mins. So like we've done in the past. So like if I were to ask you about this one, what are the turning points here? What I would expect you to do is to take your calculator out, your cell phone, since we're working from home, to graph it, and then to determine, we can zoom in by, doing the little iPhone, push your fingers together, whatever you want to call it. And you would tell me this is the minimum turning point, and this one is the maximum. And you can touch them to get them. So you would say this one here is the minimum turning point, and this one's the maximum turning point. Okay, that's what I expect on that part. The end behavior, you should be able to look at the graph and determine what happens. So on the left and on the right, the end behavior can be the same or it can be different. So on these even functions always have either points up or points down. So this one points up. That's the end behavior here. This one points down. Both the ends point down. The ends meaning after the turning points. So it has 1 turning point here. After the turning point, they both point down. This one has a turning point in the middle and then 2 turning points after the furthest from the middle turning point. So after these 2 turning points, they both point up. So it points upwards. Any ideas what this one does? This one, it points on the right, it points up, but on the left, it points down. Now, why did I write that as a line instead of writing it just like this? Well, because that's what we say. On the right it points up, and on the left it points down. So on this left side, it's frowning. So it's kind of like a goober face here. It's frowning on the left, but it's smiling on the right. So it's smiling on the right and frowning on the left. And this one's the opposite of that. Smiling on the left, but frowning on the right. So this one points the other way. Now, if I want to write that in terms of as x approaches infinity, you can do that too. So as x approaches infinity, it points up. And x approaches negative infinity, it points up. What I prefer to do is just to state what it does. It points up on both sides. It points down on both sides. It points up on the right, down on the left. Up on the left, down on the right. That's what we mean here by end behavior. Which way the graph points. Frown or smile. Alright, so to consider this, or what does it say? Consider the leading term. What is the end behavior of the graph? Sketch the graph. So what I expect you to do here again is I expect you just to graph this. I would not expect you to do this without a picture of the graph sitting in front of you. So you would literally, let me get my window so it's nice and centered. You would type this in. That's a negative 4x to the, oh, I want 3, not negative 3, positive 3, plus 2x squared plus 7. Whoops. I want the plus 7 at the end. There we go. Negative 4x cubed plus 2x squared plus 7. Let me see if I turn this light off, if that helps with the graph a little bit. Ugh, that is horrible. So bright. Let me see. This is what I need, maybe? Yeah, something like that, maybe. Something like that. Yeah, that looks pretty good. So I'm going to zoom this out. I'm going to look at this graph. So here's what I'm interested in right here. Still can't see it very well. A little brighter maybe. Nope. A little less bright. Yeah, there we go. Alright, so there's what I got. 4x cubed plus 2x squared plus 7. So it's going to start, well, let's just touch the points and see where it starts on the y-axis here. So it says it's got 2 points there of interest at 0, 7. So 0 and 7. And from 0, 7, it's pointing up on the left. So it's pointing upwards on the left, smiley face on the left. Mirror that one. And then this one here is 1/3 and then 7 1/4. Ooh, that's not 7 1/4, that's 7 7/10. So like right here. And it's going to point down from there. So it's got that, and it's pointing down from there. If I want to, I can zoom out and see where it crosses the x-axis too. So it crosses the x-axis right there at 1 4/10, comma 0. So like right here. So here's my general sketch of the graph. Alright, so what is the end behavior of the graph is the question here. That's what I've asked you here. What is the end behavior of this graph? It points up on the left and down on the right. So the end behavior is this. If you want to write it in words, you could say as x approaches negative infinity, y approaches infinity, and as x approaches positive infinity, y approaches negative infinity. Negative infinity. So those would be the words for that. What I'm going to test you on is up on the left, down on the right. Smile on the left side, frown on the right side of the graph. Alright, graphing cubic functions. I hope it's pretty obvious what I want you to do here. Type them in the calculator. Simply just type them in. So you can take your calculator out. The important points are the turning points, and then any intercepts can be important as well if they help you make a nice graph. So the turning points and the intercepts would be what I would recommend. So x cubed minus 1. I'm going to have to make sure I get my graph kind of centered well. So there's the general shape of it. Here is my turning point, 0, negative 1. Here is my x-intercept, 1, 0. And that looks pretty much like all the important points I'm going to need. So I'm pointing up on the right, whoop, and down on the left. Whoop. Now some of you are thinking, why does that not have 2 turning points like the other graphs? That's because they don't necessarily have to have the maximum number of turning points. Because this doesn't have an x squared variable or an x term, it cuts down the number of turning points. Basically what you do to find the turning points is you factor. And because this one doesn't factor with extra numbers, that's why it doesn't have x ones. So if I were to put a plus 2x in here, I would probably, or 2x squared maybe, I would expect to see more turning points, to see. So if I were to put a 2x squared in, now it's got its turning points. It's got a turning point here at the top, another one at the bottom. It's got the 2 turning points instead of just the 1. Whereas if I didn't have the x squared, which is the actual question, it doesn't have those two turning points. It just has the 1 right there in the middle because it doesn't have the x squared term. So it does matter the number of terms in terms of how many turning points you'll have. So that next one here does have an x squared term. It's a negative x cubed. And it's got the positive 2x squared, then minus x, and then minus 2. So it does have the x squared term. So I would expect to see 2 turning points here, and I do in fact see 2. One's at 1, negative 2. 1 comma negative 2. And the other one is at 1/3, negative 2. So it's basically just a little bit below it. And then it has a y-intercept at negative 2, 0. There's 0, negative 2, excuse me. So those are the important points here on this particular graph. So it's coming down. So it's got the frown face on the left. And then it's got, smile on the left, sorry, smile on the left. And it's got the frown on the right. So it has the same general shape as, this first one we did here. This one. This graph does. That way. And then this one has the shape this way. And if you do have a negative odd function, it's always going to point this way. Smile on the left, frown on the right. And positive odd function is always going to point this way. Frown on the left, smile on the right. So you can tell from the start by the lead coefficient being positive or negative which way. This way if it's a negative odd, this way if it's a positive odd. And then in terms of the evens, we've already talked about that. Frowny if it's a negative lead coefficient, and smiley if it's positive lead coefficients. All right, and that, my friends, is 3.2a. Again, make sure you're keeping up on the work and asking lots of questions. Thank you for coming.